Hi, I am Revati, Assistant Professor, Department of EEE, SNS College of Technology. In this lecture series video of electric circuit analysis, we are seeing about the topic equivalent resistance. So problem number 3. So in previous two videos, we find out the values of equivalent resistance across the terminal A and B. Likewise, we are going to solve the equivalent resistance across terminals A and B. So here we are connected with the four different types of resistance, which is 2 ohm resistor is connected in series and the other 2 ohm resistor is connected in series. So now we are going to solve this equivalent resistance. So here we know that this terminal is denoted as A and this terminal as this terminal is A and this terminal is B. So we know that which terminal belongs to this A terminal is denoted as A. So here this is denoted as BA and this is denoted as BB. So here this belongs to the A terminal and this also belongs to A terminal and this is also correspondent with the A terminal. So here this terminal belongs to the B terminal and this is also belongs to B terminal, and here this terminal is common to A and B, so that for the easy understanding we denoted it as C. Why? Because this is common to A and B. So why we need to denote as C? This is associated with A and B so that we can able to mark it as AB, right? So for this doubt, one thing we have to consider is these two are the two different terminals and two different nodes. We cannot simply like that, we cannot combine it as AB. So if you denoted with this as AB, so this terminal, this 1 ohm resistor is considered as your equivalent resistance. So that for that understanding you are denoted with this as AB. So here we have to find out the resistance across the AB, which is your equivalent resistance. So here A, B and C, three terminals are here. So we denote this as A terminal. So A, B and C. So from A we are having this 2 ohm resistor, 1 ohm resistor. So we parallelly connected this 2 ohm resistance and 1 ohm resistance. From B we are having an 1 ohm resistance to the A resistance. To A to B we are having this 1 ohm resistance. So B to C we are having. So B to B we don't have any resistance connected. So B to C we are having 2 ohm resistance. So B to C I am drawing this 2 ohm resistance. So marking this as, we know that this 2 A to C resistance is connected in parallel. So 2 and 1 is parallel in this terminals. So we know that we are using the resistor in parallel formula R1 into R2 divided by R1 plus R2. So write it as 1 into 2 divided by 1 plus 2. So that gives 2 by 3. I am taking this value as 2 by 3 itself, not simplifying the value. So after that, we rewrite this thing as, so for solving this parallel, we can get the resistance value of 2 by 3 ohms. So I am redrawn this as 2 by 3 ohms, and A to B terminal we are having 1 ohm resistance. B to C we are having a 2 ohm resistance, and A to C we get a 2 by 3 ohms resistance. So here this 2 ohm resistance and 2 ohm is connected in series. So we are applying the R series equal to R1 plus R2 formula. So R1 plus R2, so R1 is 2 by 3 plus 2 ohm resistor, we are getting 8 by 3 ohm resistance. So rewriting this equation, we are considering A to C. So from A we are having an 1 ohm resistance, and B to C we solved as 8 by 3. So this is again is connected in parallel. So 8 by 3 parallel to 1, we get the value of 8 by 3 into 8 by 1 into divided by 1 plus 8 by 3 is equal to 0.727 ohms. So the voltage resistance, equivalent resistance across this terminal A and B is 0.727 ohms. Or else we have to write it in the division format also. So 8 by 11 ohms or any other thing. So the equivalent resistance between these A and B terminals is 0.727 ohms. Thank you.